dive into the topics, as again, space infrastructure from launch to connectivity, big topic. So the first questions that I have is, what role do you see space infrastructure playing in the development of the new space, of the new business models and markets for the space industry in the next decade? And whoever would like to take that question, sorry.
I may take it, okay? I'm Jaume Sampera from SATEV IoT. As you know, we are developing an infrastructure in order to connect 5G IoT from sky. The infrastructure that we are developing, it's a wholesale satellite network that connects directly with 5G IoT devices. This means that we are being an extension of coverage of the mobile operator. This would be an infrastructure that it may be used for any mobile operator in the world, in order that when the customers that they have lose connectivity. I think that we have to get used that satellite and mobile infrastructure will be merging in one on the next years, okay? No, in the next decades, much sooner than expected. This is going to be a reality.
Okay, so I don't know if somebody would like to build on that question, but I have the follow-up question, which goes, how can we ensure that the expansion of the space infrastructure is inclusive and accessible, particularly for smaller countries and emerging space programs?
Well, that makes Martin from Eric for laser communication in spaceborne, airborne, and also on ground. If you talk about smaller countries, smaller organizations, I think there are two possibilities. The one is that we have to support building our technology on standardization, on standards. Because standards, I think, is a baseline to open all that into all the smaller countries. And if you talk about smaller countries, we also have to keep in mind that it's not only the new business models is not only referred to the countries, but especially to the industry of smaller countries. And I think for new services, for the new space industry, it's a very possibility to join then one on the standard, and the other side is the good ideas for industrialization. It's necessary to have a good country with a lot of financial power behind. If you have a good idea with respect to housing, as I just from IoT, I also was this is with IoT from space and communication, navigation, exploration. I think it's not necessarily that you have to be a big country that have good ideas. And this, I think, is a very good possibility to join that.
Yeah,
this is Sean. Sorry, go ahead, Paul.
Thanks. Yeah, so Paul Searcy with Bridgecom. So I think to add into a bit more about the standards conundrum is I think it's really important to have these networks, not just closed networks, because inevitably we're going to want to have connections between as many satellites as possible for a variety of reasons, right? The internet works as well as it does because of these telecom standards that I want to see propagated out into near Earth and even deep space eventually. But in one of the biggest conundrums, problems, sorry, using the word too many times, is the fact that the time latency in these networks is so long. We're going to have to be clever about how we make the standards actually deal with those extra strange features in the media. So in the long run, it's absolutely imperative that we come to some arrangements so that the standards make it accessible for everybody, especially folks who can't afford to put up their own constellation, but need to tap in with some sort of license fee. And the other thing is trying to make it in a dynamic way so that these connections aren't permanently just staring at each other. You know, we have a technology to do dynamic reacquisition of different users in a TDMA approach using an optical system that doesn't use gimbals. So that's one thing that I think we're going to bring to the table that makes it a lot more dynamic and useful for the lots of different users.
This is Sean Stoker from Spaceflight, and we provide rideshare services to different satellite customers as well as orbital transfer vehicle services. And I think just adding on part of that, in talking more broadly about making sure space infrastructure is inclusive and accessible, I think one of the most important things there is opening up or I should say, decreasing the barrier to entry for these smaller or newer space programs or countries. And a lot of that has to do with cost of launches. And we've seen that decrease pretty drastically here in the last several years, from dedicated rideshare missions to lower cost per kilogram with reusable launch vehicles. So I think, seeing that continue to go down is going to help to ensure that the space is more accessible to a variety of customers and entrepreneurs and innovators. At Spaceflight, we're also looking to use our orbital transfer vehicles to help to continue to grow that market and offer kind of last mile services to, if there's a common launch drop off that doesn't necessarily service all satellites, we can take customers to that desired orbit without them having to purchase an entire launch vehicle to get them there. And I think, making sure that, again, we keep that space open for a variety of countries, variety of customers. We've had the opportunity to work with over 20 different countries so far to make sure that they're able to put their technologies and demonstrations into space, and continuing to grow that market and make it accessible to a variety of players.
So,
Yeah, if I can come in on that as well. Thanks, Sean. I think that's a really important set of messages there. So I'm Lucy Edge. I'm the Chief Operating Officer at the Space Catapult in the UK, and we support all different organisations to be able to use space more effectively, more rapidly, and especially when they're not space companies. And I think that's so critical, because we know, I think, if we're reading everyone's bios, I think we're all from a background where we understand the value of space. We understand the importance of it in our progression as we go through the next decades, and benefit from all the changes and technological improvements that are going to occur. But we quite often speak to ourselves in a closed room, and we tell each other how great our sector is. And I've 25 years in the space sector as an engineer. I know lots of the people, we talk to each other, but really, if we want this to be an inclusive environment where everybody benefits from the use of space technology, this infrastructure piece has to be accessible in a way where the language we speak makes sense as well. The protocols are, frankly, invisible. That we've got to get to a point where people can use space in the same way that, I'm going to over exaggerate, but in the same way they can get on a bus to get somewhere, or call a taxi, or order something from the internet. It's got to start being that accessible. So the rideshare that Sean talks about is a really good example of where we start to make space for, excuse the pun, for organizations that aren't particularly involved in the space sector, but perhaps they want to get a sensor into space and learn how to use it. So, for me, I love the engineering side of what I do, but I think the problem I stumble upon decade after decade is that we don't speak a language that people outside of the space sector fully understand.
So
I'll introduce myself. My name is Brian Barnett, and I'm CEO of Solstar Space Company. And we're the company that's developing Wi-Fi for inside and outside of spacecraft, local area networks, as well as connecting those spacecraft to communication satellites to provide an internet link, basically secure internet link to people and things on Earth that need to interact with the spacecraft. And so I think where we can help out with connecting more and more people on Earth to space is exactly that way, to where the more that we can get our hardware and services on more and more spacecraft, then connecting those spacecraft to Earth, then that's going to allow more and more people on Earth to interact with space. And so that's what role that we're trying to play.
Yeah, and I'll kind of combine some of the things that we've heard, the good points so far. My name is Luke Gordon. I'm with Celestial. We make thin silicon-based rad-hard, highly scalable solar modules. Yeah, I think part of it also is bringing some of the well-established terrestrial knowledge base that we have and finding ways that we can best make it work in space as well. So on our end with solar energy, there's a massive power requirement even today for satellites and spacecraft. Add in a couple mega constellations that are complete, and we start to have issues not only for who's current players today, but anyone that's trying to come into that. So part of that story is continuing on R&D, a real focus on that, technology improvements, but also finding ways that we can continue to scale and decrease costs to bring as many people into the program in this world that we love as possible.
All right.
Yeah, I'd like to, oh, sorry.
All right, go ahead. Please.
Thanks. Yeah, no, I'd just like to, so I think everyone's comments are completely, let's say, focused on the matter at hand. I'm Daniel Perez, I'm the CEO of E&I Space. We work on small cost-effective electric propulsion systems for small spacecraft. And going back to the question of, let's say, what's really needed for, the space industry to start taking, like, bigger and bigger number of players. I was reading an article the other day that was saying that I think it's about 90 countries in the world now have access to somehow of some part of the space infrastructure, and that's obviously been allowed more and more recently due to the cost aspect of things, but also I think the willingness from the industry to share the know-how and to share the let's say the capabilities with other countries and other players. Of course, let's say I think everyone here would agree that the advent of very small satellites that you can put out there, kind of cost effectively and start basically effectively generating a space mission for countries that haven't had space missions is extremely important. That has to do with cost and again, knowledge base. So I think from let's say countries that are more established into the space sector, we want to see, let's say, more and more players, which eventually might also translate to more and more customers. We need to really focus on the cost, focus on the accessibility, so lowering those entry barriers. And I think one of those entry barriers is definitely also the knowledge base. But I would also like to maybe extend a question to the panel, which is we've talked to the part of the space infrastructure that is serving, let's say, the terrestrial markets. But there's, for example, on the European Horizon Europe calls, there's a lot of references now to sort of space infrastructure for, let's say, for the sake of its own infrastructure, let's say. So like an autonomous space infrastructure that is not necessarily providing, let's say, benefits to the terrestrial markets, but more as a standalone economical infrastructure, right? Things like on-orbit servicing, recycling, reuse of spacecraft, that kind of stuff. So I think, we also need to think about those kind of things moving forward, and definitely plan ahead if that's ever going to happen. The famous space economy, right, is ever going to happen. We need to plan ahead and yeah, keep reducing the cost, keep reducing the entry barriers, but also think about what's possible, not only serving terrestrial markets, but also yeah, what's going to happen out there in the next few years.
Right.
May I jump in?
Okay, go ahead. Yeah.
Oh, sorry. Just wanted to, to say a brief note about this also with respect to my my name is Anil Kumar Dev, and with respect to my former assignment as head of technology transfer at the Italian Space Agency. Now I'm involved in the PC, investing in these startups. So backing also what we said before, definitely speed is one of the main factors because of the access to data, the access to technology. I'm talking about basically both upstream and downstream application. That is very important factor. And if you look at Europe or what is happening in Europe, I'm based in Europe now. You see that there is a lot of sovereignty issues as well as access to space assets also for European community. Last but not least, what I see also from my now VC perspective is that apart from speed, more and more the startups we see are startups that have not one specific application, but they are across sectoral. So they're using space asset or space data for a lot of known space application, but with not single data from space, but data from space and non-space, or also using, this cross-contamination. So that's something interesting. And this is also why, if you look at the map from 1966 countries that were, spacefaring to 2016, so in more than 60 years, so you have seen that there is an increase of 400% of number of countries that have access to space. But it's not that they all have the capacity to send a probe to space, but it's because they are using the space data maybe to develop applications on Earth. So, the space connection, so the so-called space economy, yes, but there also has been some, differentiation on that. Sorry for jumping in, was just, to give you some hints on what's going on here in Europe.
All right. So yeah. So probably I'm the last one. I'm Hiro, Chief Strategy Officer at Warp Space, and also Chief Executive Officer at Warp Space USA. And I have different roles, such as the advisor to Cabinet Office of the Japanese government, etc. But at Warp Space, we do inter-satellite optical links. We basically provide the relay capability for Earth observation satellites and also space stations so that they can downlink more data through optical links and with less latency as we relay the data. And talking about, say, bottleneck or how we could improve the space industry in order for new entrants to basically thrive is that we believe that, last mile of the value chain of the space industry is usually regarded as like data, satellite data, right? Like launch, satellite manufacturing, those exist, but in order for like space industry to basically expand, they have to say invite more non-space industries, so that basically we can contribute more to the entire society or economy, right? And that's usually data. And these days, access to space becoming easier and easier. You see, like for example, SpaceX right here, the unit price for the satellite is like 5K per kilo. That's considerably cheaper than 10 years ago. And also manufacturing satellite is getting easier. You can find standards parts. But still say ground system, the pipeline from space to ground in terms of data, it still hasn't changed much last 1 decade. And the optical links definitely revolutionized that one. And also like relay utilizing a unique orbit such as medium Earth orbit or like a geospatial orbit in order to reduce the latency. Because today, satellite operator wait like at least 30 minutes, 60 minutes. Sometimes they wait hours or days to get the data, but we should definitely decrease it to at least like a few minutes, like the internet on the ground, so that people on the ground can use the data for many various like applications. Yeah, that's my opinion. Thank you for listening.
So while we're on the topic and while we're talking about cooperation, infrastructure development, also I want to ask you all a question, which is obviously a big question here, but obviously as we have a lot of people, I think there's going to be a lot of different perspectives on this. So how we can ensure the security and resilience of the space infrastructure against potential threats, which might include cyber attacks, space debris, and solar storms?
I'm happy to go first on that one, perhaps say something a little controversial to kick it off. I mean, I don't think we can any more than we can create those assurances anywhere else. I mean, there are a set of things we can do, and there will always be the challenges like with, whether we're talking about code breaking or physical border issues, there is always this challenge, and that challenge doesn't go away in space. And I think there was a period of time when it didn't exist so much in space because somebody's already mentioned there were so few nations practicing there, but we're not in that position anymore. And I think thankfully we've moved out of the position we were in 10, 20 years ago, where we were all pretending there were still only a couple of nations in space and everybody understood what each other was doing. And actually it had moved on from there, but our heads were still in the previous decades. So now I think we're at least much more honest about the situation, and technology will always be a huge part of a security solution. But this is no, it's not different from any other domain, and there isn't a magic answer. So it's always going to be about having good technology solutions, good protocols, and good friendly conversations with our neighbors. That's a really important part of what we do in space.
Yeah, that's all very, very on point, very true. I think, obviously the best offense is a good defense, getting monitoring systems online, but there's only so far we can go. There's a problem today. So that's where, again, like some of this R&D technology comes into play. So, in the solar energy perspective side of things, there's types of cells and photovoltaics that are less affected by MMOD. It's a very active topic now. We're all kind of diving deeper in that, the best ways to mitigate that, adjust our products, how different sizes and angles of impacts and how that reduces efficiency, what exactly happens. You mentioned solar storms, another area that is a future issue outside of monitoring. For us, with our annealing of radiation damage, we feel okay that there might be an ability to knock it out and come online with some of the doses that we've accumulated in the past being higher than an average solar storm. But I guess all of this to say is an agreement with Lucy is let's talk to each other, be conscious about what is existing already, and then keep developing technology that can best adapt and work with our system that we're setting forward.
Yes,
Sorry. Oh, go ahead, John.
Okay, thank you. Thank you, Paul. Okay, I think I fully agree with Lucy. Okay, we have been for the last 20 years thinking about as a satellite as a trust node that it was secure because it was in space, and this is an end. Okay, we have seen during the war of Croatia that some big players have already had huge problems because of cybersecurity attacks to satellite, and we have to be conscious, okay, that the information of our customers, it goes from one satellite to another, and we don't have to think again that this is not going to happen. We have to protect, okay, we are in a couple of projects with the European community about QKD in order to secure the nodes between them. And I think that the way to do it's to think that we are on the same position as a terrestrial node right now.
Yeah, I was just going to try to contribute from. I'm not a lawyer of any stretch in the world. I'm pure technocrat. But what I'm concerned about is I think we as an industry need to be proactive in terms of dealing with the fact that somebody's satellite explodes, they cause damage to somebody else's satellite. What's going to happen? I think it could turn into a big dose of cold water on the whole market, and that would be a tragedy. So I think instead we really need to think about how to mitigate those things. Luke, if you've got technology that can make the solar panels more resilient, that kind of thing could be really powerful, and hope to keep I think we need to keep our foot on the accelerator on all of this infrastructure, because it's the underappreciated underpinning of civilization. So as we move into near space and deep space, got to have ways to keep things from getting derailed into a court battle or something.
Okay, so now moving on, and I have a question here for Sean Stoker. So Sean, question for you. How can space infrastructure impact organizations looking to reach orbits beyond LEO? Thank you.
Yeah, thank you. So I think, the development of space infrastructure is enabling satellite companies to reach orbits beyond LEO by providing tools like orbital transfer vehicles that expand the capabilities of launch vehicles and extend the lifetime of spacecraft. So we're seeing a lot of, call it, commoditization of low Earth orbit rides with different rideshare launches, and really bringing that cost down. But what we haven't really seen yet is for companies and people that want to expand beyond LEO, and how we're able to do that. And that's one of the arenas that spaceflight is delving into with our Sherpa OTVs, is looking to provide that service to customers that aren't necessarily on a dedicated launch, but how can we work with launch providers and other primary customers to take whether it's a satellite and drop it off in orbit beyond LEO, or kind of tying it back into the space accessibility discussion. If we've got a customer or a company that has a piece of technology, but not necessarily the know-how or the infrastructure to create their own spacecraft, how can we accommodate them or host them on our OTV and be able to have them, test their hardware and provide that infrastructure for them. Currently OTVs can provide in-space transportation of satellites from the launch vehicle's final drop-off to their desired destination. I think that this allows the spacecraft to propel to further orbits. So really, it's looking at how do we expand this commoditization beyond LEO and really start looking to orbits further out to service more companies and further more technology and help build that infrastructure.
So as the question follows, as we have different players, again, from different industry segments here from the space industry, how can public-private partnerships and international collaborations be leveraged to accelerate the development of the space infrastructure and enhance global space capabilities?
I think it's essential that the idea of governments working with commercial space companies like all of ours is really important to advance and make commercial space happen, because it's still really, really expensive to get to space. And I think one of the best ways that federal government can help to spur commercial development in space is to partner with us to help us with the transportation costs to get to space, so that we can test our technologies and our products. So I like to say that at pretty much every conference that I'm at. NASA has a good example. NASA has an organization called the Flight Opportunities Program, where you can compete to test your technology in space, and then NASA pays for that transportation cost. So it's very competitive to get those rides, but we were able to take advantage of it. We have to invest our own money into for instance, developing the Wi-Fi hotspot that we flew inside the crew capsule of Blue Origin's New Shepard a couple of years ago to demonstrate a satellite link to the spacecraft. But I have to say that just being able to share those costs with the federal government really, really helped us. I mean, we invested a lot of money ourselves, and that's where these partnerships can help out. And I recommend that to other countries as well. I think that's probably one of the best ways to get people and companies involved in your country, to be able to have, if you can help them get access to space, that's about the best thing that the government can do for your citizens.
If I may jump on this. Oh, sorry.
So no, I was just going to say that I think both myself and Jaume are in a kind of like interesting situation, because the Spanish Space Agency is just about to come online in the next few months. And I think that's a great example of basically like government understanding, first of all, that like space is a strategic arena, both from the public and private perspective. But I also have the feeling that, at least particularly for us, what's happening basically is that this will be an agency that's going to be directly working with the commercial companies in the country, right? And I think we've taken an example from NASA on like recent years, right? Collaborating a lot with like more and more commercial companies to be their first client. That's a massive of massive importance, let's say. So when nobody trusts you to have the space agency be able to, or your own space agency be able to take that risk, trust you with a new technology, trust you with a new business model, that's absolutely fundamental, so that you can go and provide that business model to others. But also, let's say that huge focus on, hey, we're going to do things in space, and we're going to basically bet on the industry to carry out those developments. That's something that, of course, European Space Agency has also been doing. But I think there could have been many ways in which this kind of like new public institution came out, and we've been lucky enough to probably have what I think is the right way to go, which is like an agency that ensures that the public-private collaboration is gonna be at the basis of things. So yeah, we're very lucky in that sense, I would say.
Okay, and I have a question here for Luke Gordon regarding your services. So question, Luke, here as follows: where do you see solar power role in all this developments, and how does Solestial enable us to power our in-space assets? Thank you, Luke.
Yeah, I think part of it comes down to the future as just a math problem. There's just a lot of power requirements, and we're starting to see hiccups in various parts of the supply chain, or at least some scares. And so companies like Solestial being able to utilize these well-established terrestrial processes and techniques to turn a product into something that can withstand the harsh environment of space, I think there's a lot of value there, mainly from a price and a scale standpoint, that can kind of unlock these larger scale infrastructures after some of these large launch vehicles come online, and we start to see the new space economy really kick off. I think moving from both the service and the service standpoint, component, product, maybe we're in a different type of model, and a service model in the future, but also just a scale. This allows us to move from where we are today to a ultimately maybe like a utility scale infrastructure, where there's different types of solar energy and other types of energy that can just kind of help be that backbone, help be that infrastructure to unlock everything everyone else on this panel is looking to do at a low cost.
All right, thank you for that, Luke. The last question.
If the connection is assisting me, sorry, just wanted to just throw out my 2 cents about the PPP. So looking at the startups, previously the public-private partnership was like, okay, I'm a private guy and the public should give me the money. Now it's different. It's like, okay, I know that the money cannot come from them, but maybe we need from other sources, but the public entity should give me maybe assets to support me in access to infrastructure, assets, or so on. And this is also what's happening in some European entities, as well as also with the new, Vision 2030 from ESA, the European Space Agency.
Thank you, Anil Kumar. Last question here for the panel. With the still 3 minutes to go, and just I would like everybody to comment on this also. With the increasing privatization of space exploration, how do we balance commercial interest with the public benefits and global cooperation in the development of the space infrastructure? Thank you.
Yeah, may I comment then? Right. So I think one was a deep space exploration by a private company would be like iSpace, right? I said a Japanese company, and well, it's good that private companies can also get involved with exploration, space exploration, especially deep space ones. But yeah, if as one was an issue, you actually, yeah, just you mentioned that if everybody does the different things, it's difficult to collaborate in a way. Yeah, we need to be very, for example, interoperable or compatible. That's where I think we can go back to the original discussion of the standardization, or maybe PPP, like private public partnership, like a discussion should be led by probably governments or like an intergovernmental organization. That's really important. Otherwise, well, we're gonna have lots of issues with compatibility and interoperability. That's also include optical communication as well.
Answering your question, I think that, of course, it has to be regulated, but at the same time, we have to give the private companies all the space to develop. We have seen in the past, okay, that the private companies is the more efficient. It had been historically, okay, more efficient than the public organization. And they think that if we all together regulate the space, this would be the best way to access.
I think there's a really interesting intersection between public policy around nuclear power as well as the math, as I think Luke said. We need, in my opinion, we need nuclear power and we need nuclear sources in space. That's the most logical place for them. But at the same time, if that risks public health, then we have to balance that between the two. But I am curious. It'd be nice to sit down with the group and kind of figure out where that's going to go, because I think if we don't have nuclear in space, we are missing a big opportunity and we're really slowing our acceleration down a lot.